Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good day. So it's been a long time I didn't upload my YouTube video. So today I have a time because we just recover from the fever. So I have taken some annual leave to recover from it. So let's do some video. Okay, this video is about response surface methodology. Quite short and simple video. So when we are doing the optimization process, often we are trying to get the correct model. Either we want to use the box beacon BBD, the central composite design CCD, the dollar, the DOH, how to spell it, the dollar, 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 DOEHLERT, dollar model, or other kind of model, for example, full factorial, Taguchi, and also optimal design. So, how to choose the design to model your optimization? So normally in my case, in my experience, so I have used the central composite design and also box beacon, but I never tried the other like dollar design, factorial Taguchi, also optimal design. But today we're going to discuss some of the key points why we choose that design. So number one is about the structure. So because my expertise on the CCD and box beacon, majority we discuss between the central composite design and also box beacon method. For central composite design, the structure contains full factorial, whereby we have the center point and also we have the axial point. They tend to go to very critical value, the maximum and also the very minimum, and also the central. So when you expected your model to have a curvature, go for central composite design, because central composite design is the best, because the efficiency, when we are talking about efficiency, is high prediction efficiency. Means that when you calculate the residual standard error, your residual standard error will be very less. So it's very good for quadratic and even for cubic model. That's for central composite design. And when we jump into the second model, we are talking about box beacon. When compare in terms of number of run, central composite design of course have slightly more number of run compared to box beacon. And for box beacon, the good thing about box beacon is box beacon you have slightly reduced number of run. And in this case, box beacon also consists of the midpoint of edges of factorial, but does not use the corner point. It will not go to very maximum and also very minimum. So that's a very good thing about the what we call that the box beacon. And in terms of the efficiency, quite efficient compared to CCD. And for the application, if you believe that your system will collapse at crucial or very maximum and minimum factor or limits, then you can go to the box beacon. When compared between box beacon and also central composite design, both is quite good, both is effective to determine the optimization of your parameter. So yeah, when we talk about curvature, the best thing if you expected a curvature, for example, when we say in CCD, you got the middle point, the lowest one, and the maximum point. When you expect a hyperbolic curvature, the best thing go for the CCD. But for box beacon also can, it's no problem. Okay, and both is good for the quadratic and also cubic design. And what are the other model? The other model is like dollar design, which is use spherical design with hexagonal layout. I never tried it. They said it's very useful if you have a lot of factor. You can use dollar design because it have much lower in term of number of run. It's dollar design. So I never experience and never do that. So that's the other one. And if you want to do a very complex study, you can go to the full factorial design. So of course the number of rounds will be more and bigger and bigger. That's the full factorial design. And last but not least, if you want to use your own design, go to optimal design. So optimal design is like custom build. You can custom build your design like you want to determine at which parameter, which temperature, which pressure and so on. You can use your optimize or you can custom build yourself. So basically, if you try your best using central composite, you try using box beacon, it doesn't work because you want a certain parameter to be your own value. Go for the optimal design because in the end, from the ANOVA analysis, you will observe the R square, the lag of feed, you will observe the response, the what we call that the distribution of the arrow. Is it the arrow is normally distributed, the what we call the actual and also the predicted, is it aligned in the straight line, is it the data on the range or not. Everything need to be considered. It doesn't matter what is your design, but the best thing is what you need to consider is what is your result, what you expected. Because before we go further into doing an experiment, we need to know the problem. And after knowing the problem, to solve the problem, you need to come out with a hypothesis. Hypothesis is like early conclusion. You need to predict what is the response it should be. Then by predicting, if you predict there will be a strong curvature, go for central composite design. I think that's all. See you again. Bye bye.